You've probably heard of the Airbus A380, the biggest passenger plane ever flown. But here's what you haven't heard. Airbus built just 251 of them, shut down the production line in 2021 and walked away. Not because it crashed, not because it failed a safety test, because the world it was built for never showed up. So what did Airbus build, and what went wrong? Why did A380 fail? Airbus made a bet in the 1990s. The future of air travel, they believed, would run through massive hub airports, places like Dubai, London, and Singapore, where enormous planes would funnel hundreds of passengers together before redistributing them across the globe. Pack enough people onto a single aircraft, and the cost per passenger drops to something extraordinary. The A380 was built entirely around that vision. But airlines had a different idea. Passengers didn't want to connect through hubs. They wanted to fly straight from one city to another, point to point, no layovers. Newer aircraft like the Boeing 787 and the Airbus A350 made that possible. Both were smaller, burned less fuel, and could fill their seats on routes that would never support an A380. They gave airlines flexibility. The A380 demanded volume. To turn a profit, you needed close to a full cabin, every time, on every route. There are only so many city pairs where that's realistic. Airbus eventually ran out of buyers. The airports didn't help either. Before an A380 could land somewhere new, that airport had to earn it. Runways needed reinforcement. Taxiways had to be widened for the 260-foot wingspan. Gates had to be rebuilt with multiple jetways to board passengers across 2 full decks. Heathrow, Dubai, and Singapore all spent heavily on A380-specific infrastructure. Smaller airports never bothered. Assembling the aircraft was its own undertaking. Wings from the United Kingdom, fuselage sections from Germany, Spain, and France. Everything shipped to Toulouse for final assembly. And some parts were so large that roads through rural French villages had to be widened just to let the transporters through. The A380 required an entire continent just to build it. How big was it? Start with the wings. Tip to tip, the A380's wingspan runs about 260 feet, roughly 9 full-size school buses lined up end to end. But the more surprising fact isn't the size, it's what those wings are designed to do. They flex. During a normal flight, the wingtips bend upward by a few feet under load. That's not a flaw, it's intentional. A rigid wing would transfer every jolt of turbulence directly into the fuselage, and over thousands of flight cycles that stress accumulates. The flex absorbs it instead. Think of it like the difference between a wooden plank and a suspension bridge cable. One snaps under pressure, the other moves with it. Airbus tested this well past anything the aircraft would face in service. Engineers loaded the wings in a static test rig, pushing the tips farther and farther upward. Not flying, but bending them deliberately until they finally gave out at nearly 25 feet of deflection. The wings reached angles you'd never expect metal to survive. Below those wings sits a fuselage unlike any other passenger aircraft. The A380 runs 2 complete decks from nose to tail, not a partial upper section the way a Boeing 747 does, but 2 full floors running almost the entire length of the plane. Depending on the airline's configuration, it carries between 500 and 853 passengers. That's not a plane. That's a small town at 35,000 feet. What happened inside? Some airlines looked at all that space and got creative. Emirates installed private shower suites in first class. Not a damp cloth and a basin, actual showers with hot water on a passenger aircraft cruising at around Mach 0.85. Other carriers built stand-up lounges and bars where passengers could stretch their legs mid-flight. The A380 gave airlines square footage they'd never had before. Then there's the sound. Your instinct says a plane this heavy and over £1 million at maximum takeoff weight should rattle and roar. Passengers consistently report the opposite. Part of that comes down to mass. A heavier structure absorbs vibration rather than transmitting it. The 4 turbofans are also mounted far out along the wings, placing them as far from the cabin as possible. The noise travels outward rather than inward. The result is a cabin that feels almost unnaturally still, quiet enough that you notice it. So far, you've seen what the A380 could do: a flying village with showers, 2 full decks, and an evacuation system that defied belief. But none of that explains why this aircraft needed 4 engines when every other long-haul plane uses 2, or why the pilot measures speed in a unit invented before the steam engine. Both answers trace back to the same forgotten history. How did it fly? Most long-haul aircraft flying today run on 2 engines. The A380 uses 4. That wasn't arbitrary. When Airbus began designing the aircraft in the early 1990s, 4-engine jets were still the standard for ultra-long-haul routes. Twin-engine jets had only recently gained approval to fly extended over-water routes under ETOPS regulations, and those approvals, while expanding, weren't yet the industry default they are today. 4 engines gave operators confidence and flexibility on the longest routes in the world. As twin-engine reliability continued to improve and ETOPS approvals widened further, the case for 4 engines gradually weakened, which is part of why 2-engine jets now dominate long-haul flying. But the part most passengers never think about is what's happening with the fuel. Their A380 carries up to 84,500 gallons of fuel, enough to fill a large backyard swimming pool more than 4 times over. That fuel doesn't sit in a central tank. The aircraft actively moves it. Pumps transfer fuel between tanks in the wings and tail, continuously adjusting the center of gravity as the load decreases. The goal is twofold: keep the plane balanced and reduce drag by trimming its pitch. While you're sitting doing nothing, the aircraft is managing its own weight distribution in real time. Spread that fuel burn across 600 passengers and the A380's efficiency per seat becomes genuinely competitive. What happened to the A380? Airbus delivered the first A380 to Singapore Airlines in 2007. For a few years, it looked like the hub model might work. Emirates became the aircraft's most committed operator, eventually flying more A380s than any other carrier. But the orders never followed Airbus's projections. Airlines that might have bought the A380 chose the 787 or A350 instead. The economics of filling 500 to 800 seats on a consistent schedule proved harder than the spreadsheet suggested. Airbus announced the end of production in February 2019. The last aircraft rolled out of Toulouse in 2021. Final count: 251 aircraft across 14 operators. The plane never failed. Passengers rated it among the most comfortable experiences in commercial aviation. Pilots respected its handling. It met every certification standard demanded of it. What the A380 couldn't survive was the gap between the future Airbus had planned for and the future that actually arrived. The world didn't stop flying, it just stopped flying the way Airbus expected. Why do pilots use knots? The A380's story is done. But before you leave that cockpit, there's one thing worth noticing. The captain announces cruising speed. The number isn't in miles per hour, it's in knots, the same unit on every flight you've ever taken, the same unit on every ship crossing every ocean right now, the same unit in use long before the first aircraft left the ground. Nobody switched it out. Why? The answer starts in the 1600s with a piece of wood and a rope. Sailors tied physical knots into a long line at intervals of exactly 47 feet and 3 inches, attached a weighted float to the end, and tossed it overboard. As the ship moved forward, a sailor counted how many knots slipped through his fingers in 28 seconds. That count became the ship's speed. 1 knot counted, 1 nautical mile per hour. The spacing wasn't random. A nautical mile was defined as 1 minute of latitude, 1/60th of a single degree on the globe. It meant the map and the measurement were the same thing. No conversion tables. The math lived in the rope. When aviation began, the first long-distance pilots used maritime charts and maritime formulas, so they used maritime units. Those units stayed because they still work. A flight from New York to London follows the curve of the Earth. Statute miles are a land-based measurement that loses accuracy over distance. Nautical miles don't. They're tied to the planet itself. The A380, a million-pound aircraft crossing oceans at nearly the speed of sound, measures its speed the same way a wooden ship did in 1650. Some systems are so well designed that the centuries just leave them alone. If there's something you walk past every day and wonder about, drop it in the comments. We read every single one, and the best suggestions make it into future videos. Don't forget to subscribe so you don't miss what's coming next.